How you doing, Year 10s? Welcome to another video. This one's on acids, so let's get stuck into it. Okay, so 3.2b, what are the types of chemical reactions? This episode we look at reactions of acids only. Now we need to be able to write worded and balanced chemical equations for the reaction of an acid with a reactive metal, a metal hydroxide, a metal oxide, and a metal carbonate. The acids that you will need to know will be limited to hydrochloric, sulfuric, and nitric acid, and you need to remember the formulas for those three acids. Make sure that you remember them: hydrochloric, sulfuric, nitric. So here are our three acids. And what is an acid? Well, an acid is described as a substance that can donate a hydrogen ion or a proton. Some of the things you might remember from Year 9 is acids, they have pHs less than 7 and they like to react with bases. The three acids we need to know: hydrochloric acid, HCl aqueous, it can be found in brick cleaner and in your stomach. Nitric acid, HNO3 aqueous, that's found in fertilizers because it contains the nitrogen. Plants need the nitrogen to grow. And sulfuric acid, H2SO4, again aqueous. All of the acids will be as aqueous, and they can be found in car batteries, sulfuric acid. So the first one, acids reacting with reactive metals. So reactive metals are metals found in group 1 or group 2 of the periodic table. Also zinc is considered to be a reactive metal as well. So the reactive metals might include calcium, magnesium, potassium, and zinc, but non-reactive metals are copper, gold, and silver. They're not as reactive. Now when acids are added to main group metals and some transition metals, bubbles of hydrogen gas are released and a salt is formed. The thing that you need to remember here is hydrogen gas is H2. A lot of students will just write hydrogen as H, hydrogen gas is H2. So here we have an example: a strip of zinc metal is added to a nitric acid solution. Write a balanced chemical equation. So we have zinc, it's a metal, it's a solid. We've added that to nitric acid, which will be aqueous, HNO3. And our salt will be the zinc and the nitrate, because that's the ionic bond, zinc and nitrate. And we have to get the formula right, and then we have our H2 gas. Then we need to make sure that it's balanced, so I have one hydrogen on the left and I have two hydrogens on the right. So I need to put a 2 out the front of the nitric acid, and that also balances our nitrates. This is why it's important that you get the formulas of those ionic compounds right. Zinc, nitrate, need to be able to get that. Acids and metal hydroxides. A metal hydroxide can be considered as a base because it has the OH group, and that is described as a neutralization reaction. Neutralization produces salt and water. So metal hydroxides, NaOH, CaOH2, MgOH2, and we describe these metal hydroxides as being basic or alkaline. So an acid plus a metal hydroxide will form a salt and water. So for instance, calcium hydroxide is added to a solution of sulfuric acid. We need to get the formula of calcium hydroxide right. So we have a calcium ion, a hydroxide ion, and the formula would be CaOH2. That is going to be a solid because they said it was a solid. It comes in these tiny little pellets. And then we add that to our acid. Our acid will be aqueous. And then we form our salt and water. So our salt will be made up of calcium sulfate, and then the water is just H2O. Now calcium sulfate, calcium is 2+, sulfate is 2-. So when I put those together, they're nicely balanced, and my water will be H2O. Is this one balanced? Well, if you just have a look at the hydrogens, well, we have 4 hydrogens on the left and only 2 hydrogens on the right. So I need to put a 2 out the front of the water, and then that will also help us balance the oxygens. Acids and metal oxides. Metal oxides are also considered to be bases or alkaline because they contain the oxide ion. Metal oxides also undergo neutralization reactions with acids to produce the salt and water. Metal oxides, Na2O, MgO, CaO, ZnO, and they're all solids. These things are very hard to dissolve. So they will form a salt and water. So powdered calcium oxide is added to hydrochloric acid. We need to write the balanced equation. Got to get the formula right. Calcium is 2 plus, oxygen is 2 minus, so the formula is CaO. It's a solid. We add it to our hydrochloric acid, which will be an aqueous solution, and we're going to form our salt. Here our salt will be calcium chloride. Now we've got to get the formula right. CaCl2 aqueous plus H2O. Is this one balanced? No, it's not balanced. Look at the chlorines. I need 2 chlorines on the left to balance for the 2 chlorines on the right. So I stick my 2 in front of the HCl and that one is balanced. Okay, an acid and a metal carbonate. A metal carbonate is slightly basic because it contains the carbonate ion. When the carbonate ion reacts with an acid, it decomposes into carbon dioxide, and then the remaining oxygen ends up in the water. So we have an acid and a metal carbonate. It reacts to form a salt, water, and carbon dioxide. So for example, sodium carbonate is titrated or reacted with sulfuric acid in a volumetric analysis. Sodium carbonate, we've got to get the formula right, Na2CO3, because sodium is only 1 plus our sulfuric acid, which will be aqueous, and that's going to form our salt, Na2SO4, because again sodium is only +1 and sulfate is -2, plus our water, H2O, plus our carbon dioxide. So our carbon dioxide will be at the end. Now we need to balance this up. I've got 2 sodiums on the left, 2 sodiums on the right, so that's pretty good. I've got 1 sulfate on the left, 1 sulfate on the right. Let's just have a look at the carbonate. So the CO3, well, it breaks down into CO2, and then the extra oxygen is in the water. So this one is balanced. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe if you're new, and practice those balancing.